All right, can you confirm that you can see my screen?
Indeed, you're looking great.
Hey everyone, thanks for joining. Wanted to introduce myself. My name is Mayank Dalramani. I'm a Senior Alliance Manager here at GitLab. Today I have with me Kelly here, a Senior Solutions Architect at GitLab, as well as Kamal, a Senior Solutions Engineer at HashiCorp. Super excited today to be talking to you about how our two companies and products are working together to bring to market a fully SaaS-based DevOps solution. And by fully SaaS-based, we're talking about no need to self-manage or host any components. It's a matter of clicking and subscribing and creating an account on Terraform Cloud or GitLab.com. So to get started, I wanted to level set and give you a quick overview of GitLab and Terraform together. GitLab is a complete DevOps platform delivered as a single application. For those of you who may not be familiar with GitLab, it does much more than just store your code in SCM, create CI/CD pipelines for continuous integration and delivery, but it also facilitates collaboration across various different teams. You can have different engineers, project managers, product managers, all collaborate on a single application where they can go from an idea to production much more quickly. And how we do that is through an array of features found in GitLab.com, all the way from product and portfolio management, creating epics and issues to map out what ideas and iteration and sprints are going to look like for feature enhancements, storing your code and reviewing your code in SCM, building out automation pipelines with CI/CD, securing your code with SaaS, DAS, and vulnerability scanning, and all the way into deploying into production. Really, the goal for GitLab.com is to reduce the friction and cycle time to roll out ideas into production much more faster. Complementary to GitLab.com is Terraform Cloud, another SaaS offering that's enabling organizations to scale infrastructure as code safely through collaboration and governance. If you're familiar with Terraform Cloud, you probably recognize that you can pretty much define your infrastructure at a desired state in a YAML file and execute a plan for Terraform to apply and execute. Basically, you can modularize and reuse these modules and store them in a shared repository, thereby enabling developers to quickly provision in a self-service fashion. This is my desired state. These are the components I need. Here's the infrastructure I'd like to provision, and then go ahead and execute. With Terraform Cloud, you have the Enterprise Edition as well that includes Sentinel, which is HashiCorp's policy as code framework. It allows logging and enabling organizations to secure, govern, and audit their entire deployment. What that means is, if they're requesting, say, an infrastructure resource, Sentinel will then validate if they have access and permission and capabilities to request that resource and have it provisioned by Terraform on their behalf. So there's a lot of bells and whistles and really cool functionality in Terraform Cloud, and I think it works amazingly well with GitLab.com, completing that whole DevOps story. Today we have with us, as I mentioned, Kelly here and Kamal. They'll be doing a quick demo on how our two products work together. So I'll hand it off to Kelly to give you a quick overview of what to expect in the demo and the various components that we'll be showcasing shortly. Kelly, can you take it from here? You're on mute, by the way. You're still on mute.
I'm on mute. There we go. All right. So let me go ahead and share my screen. Thank you so much. All right. So can you see my screen okay?
Yep, I can see it.
All right, awesome. I'm just going to pick up where you were, Mayank. So thank you again, Mayank. My name is Kelly here. I'm a solutions architect. I think I already said that again, so I'm just going to be redundant. All right. I work with the Alliances team with Mayank and some other folks, and also with wonderful partners and with like HashiCorp. All right. So on your screen, what you're seeing is we're going to walk through the demo. You're basically looking at a graphical representation of what the CI/CD pipeline looks like in GitLab. What happens, where it hands off. So just walking through, there's a few different stages that are associated with this. There's a create workspaces, a set up workspaces, a get credentials, a run, and destroy. So those are stages that can have one or more jobs. So you can see one on the screen there. There's basically a job per stage, except for setup workspace, which actually has a couple jobs that run. What the portions of the create workspace and setup workspace and get credentials are all pretty much happening on GitLab. The run stage itself, the Terraform apply, is basically sending a request over to Terraform Cloud And the Terraform Cloud is checking governance, so it's looking at Sentinel policies or policy as code to see if the policy is being met, and if so, the infrastructure will be deployed. So let me go ahead and just walk through what this looks like. As far as on getting more into the Sentinel policy, I'll hand the mic over to Kassar to get into more detail there. But this is basically showing what I mentioned as far as GitLab interacting with Terraform Cloud, the plan and apply happening there, but then Sentinel policies are in between. All right, so let me go ahead and get into the project itself. And what I'm looking at here is this is a real live project. It is publicly available. So if you'd like to take a look at this later on, great. What we're going to do is we're going to tag this as version 1.0. So any subsequent changes to this project as we continue to enhance it, we'll actually have perhaps a newer, you'll see a newer view of that. But if you look, there will be a drop down here. We can actually look at version 1.0 within the tags and see that. It'll also show up here within the brand, within the releases. Right now, there's no releases, but I'm going to create that right after this recording. All right, so let's go ahead and take a look at the pipeline view. These are all the different pipelines that have run. As you can see, we've tested this out pretty well. There's one, in fact, it looks like there's a previous go around, which I'm going to go ahead and run now, so we'll have a clean pipeline. I'd actually just merged in a change on one of the files, so that's why that had run. All right, so we're just going to give that a second to go through and clean up the infrastructure so that we can kick off a brand new pipeline that goes through the whole process. All right, so we saw the graphic earlier that had the different jobs and stages lined up. So this is the same view. What I'm going to do now is I'm going to go ahead and basically bake the cake, since we already had the cake baked a few times there, but we're going to go and bake the cake off of the master. So I'm going to do a manual pipeline run. Typically, a pipeline will automatically start once a developer checks in code, or an infrastructure engineer checks in some Terraform files, or whatever it may be, right? So whenever something's checked into the Git repository is when the pipeline will run. I'm going to manually kick it off, though, as opposed to waiting for some kind of change within the repo itself. So with respect to GitLab, what we do is we actually have we have runners that basically pick up jobs, and they'll execute those jobs within the different stages of a pipeline. There is in the root directory of a project itself is where we basically have a spec that has all the setup that's required to run that CI/CD pipeline. I'm not going to really run through this. There's some comments in here. You could take a look at it later if you like. But just wanted to ensure that you knew that this file was what GitLab was looking for to run a pipeline. We do have something called auto DevOps, and that's a little bit different, where we automatically figure out what languages are being used, and that's more for programming languages. For Terraform, there is a spec that was created specifically for this. All right, so let's go ahead and go back to the pipeline itself and see what's going on. We kicked off this job, and it looks like it's humming along. So let's go and dive into it. Right now, we've done it, create workspaces. What this is doing is it's basically creating a workspace ID. So it's either creating or reusing, depending on what Terraform Cloud provides back to GitLab. Right. So the next stage is we set up the workspace, where we basically set up some different variables, ensure that everything is set up within Terraform Cloud. And then next we're doing Git credentials, which is going back to Vault, and basically getting the credentials for GCP. Next is really where we kind of hand off back over to Terraform Cloud to do its thing. So what I mean by that is that we are sending over a job to Terraform Cloud. Let me just go and grab that and pop it in here. We're sending this over to Terraform Cloud to go through and provision that infrastructure. What is provisioning is very simple. It is a Google Cloud instance that has a simple application that basically shows what visitors have visited the site itself. That being said, it looks like it failed. It looks like the Sentinel policy was not checked. So it looks like, what does it say? Okay, we tried to specify a different machine type, what was allowed in the list. So we were allowing an N1 standard. And as far as the Sentinel policy, again, I'll hand that over to Kassar to get into more detail. But that being said, for now, I'm going to go ahead and override that policy and say it's okay this time. And again, this is on Terraform Cloud itself, so this is outside of GitLab. So the idea there is that you may have some governance where you have perhaps an infrastructure team that manages Terraform Cloud, and then you have a developer team or a DevOps engineer or whatnot that is in GitLab itself. All right, so I'm going to go and override this because I have the right to do that. Typically, there will probably be a separation of duties, so there may be someone else that does that. But that being said, now the Terraform apply is kicking off, and it looks like it is creating resources in GCP. And any second now, what will happen is that it'll come back and tell us what our there we go. There's our IP address. If anybody wants to hit this IP address, oops, let me go back to that. If anybody wants to hit this IP address, you will see that we have visits here. Now, that being said, this is being recorded, so I'm going to destroy this pretty quickly. So I guess that's probably not quite possible, but you just reload this site. Looks like it's still coming up. That was cached from a previous run. And there we go. Now it's up and running. So if Mayank and Kassar wanted to hit it, then we would see perhaps, well, we'd probably still see Max as well. Doesn't look like we have the IP address on the details, which is, thank you for not sharing that, Kassar. All right, so let me go ahead and just show that I've hit this a couple of times and it continues to roll up. So this is my laptop, or the GitLab laptop that I use. That's basically showing that I've visited the site. All right, so the next thing I want to do is I want to go back over to Terraform Cloud, and I'm actually going to now destroy this. So let me go ahead and go, oh, actually I take that back. I want to actually go back over to GitLab, because what I want to do is, since again, I requested infrastructure, I want to go ahead and destroy it there. All right, so you can see that right now there's a destroy, it's been skipped. That's because there's a manual job. So this is the nuance between continuous delivery and continuous deployment. That we can gate different items within GitLab. So different stages can be gated. So like, say for example, you have a QA team that wants to test out a new application or a new website before that goes out to the general population. Then it was very easy for me to say, obviously, to the general population. Then you can do that. You can actually have the continuous delivery aspect. You know, web scale companies are going to be more continuous deployment, where it just goes straight into production. There's automated testing throughout, and this really skims the surface of what testing GitLab can provide automatically. We can do a lot of security testing as well. We've stayed away from that. We've made this very simple to ensure that we have the cohesion and between the two different products. All right, so we go and destroy this infrastructure. So this is running a Terraform destroy. It is actually going back to Terraform Cloud. So if I go to my runs here, let's see here. There we go. Looks like on Terraform Cloud, it is going through, and let's see what happens here. Hopefully it all destroys. By the way, let me go ahead and refresh this site. Looks like it's still going, still going, still going, still going. Still going. Okay, it looks like it's going to do its destroy here shortly. So I'm just going to keep on pressing enter, so you can see that the visits are rolling up because the infrastructure is still deployed, right? Terraform is actually going through here to destroy all that. So it looks like, oh, here we go. So now the destroy is about to run. So let me go ahead and keep on pressing enter. Now it's destroyed. Game over for me. All right, so now it's going through, and Terraform Cloud is going through and destroying the instance itself. And then the pipeline itself, you can see also it's been updated because it's done everything it needed to do on the GitLab side. So hopefully that makes sense as far as the interaction between GitLab.com Terraform Cloud. We're basically doing stuff on both sides. It's great. As Mayank had mentioned, we're basically mirroring the two of those together to basically make it better. So with that, Kasar, perhaps you could get more into, go and stop sharing. Maybe you can get into more details on the Sentinel policy and some of the other Terraform bits that I didn't cover.
Yep, I'll be happy to. Thank you, Kelly and Mayank, for that excellent demo. So can you share my screen? I mean, can you see my screen? Sorry.
Yep.
Yes,
I can see
indeed.
it.
Yep.
Awesome. All right. So yeah, as Kelly showed, there are quite a few different parts that are interacting together. So I just wanted to provide an overview of that and go into the Sentinel policy and the Vault configuration. So essentially, GitLab in this case is being used as a version control repository and also as a CI/CD pipeline orchestrator. So your Terraform code and your Sentinel code is being stored in the version control repository. And then the pipeline itself is grabbing some secrets from Vault. So Vault is another product from HashiCorp, provides secret management and encryption as a service. So in this case, Vault is providing the Terraform Cloud credentials, which is an API key that GitLab CI/CD needs to interact with Terraform Cloud. It's also providing temporary GCP credentials, so we call this dynamic secrets. So essentially, these credentials are valid for a configurable amount of time. So in this case, it might be valid for 30 minutes, after which Vault will destroy those GCP credentials. So once it gets those credentials, it will actually, so the pipeline is using a runner that's deployed in GKE. In GitLab, you can have both shared runners and dedicated runners. In this case, we went with a dedicated runner in a Google Kubernetes engine just because that's where Vault was running as well. It made for a very easy setup, but in a future version, we may just end up using a shared runner. Once GitLab runner has all of the credentials, it then sends the REST API request to Terraform Cloud, which you can see here. We already have Sentinel policy set up in Terraform Cloud. As part of this workspace, Terraform Cloud can pull the Sentinel policy directly from GitLab using a OAuth integration. Assuming that the Sentinel policy checks passed or it was overridden on a soft failure like Kelly did, it'll go ahead and provision a VM in Google Cloud Platform and deploy an application on top of that as well. So that's essentially the demo you just saw. I was just summarizing all of the different parts that are working together. The only other thing I wanted to mention is we have a Sentinel directory in this repository. In that directory, there is the Sentinel policy, which is restrict GC machine type. It's actually easier to read Sentinel policies from the bottom up. So you see that we have a main rule. The rule is saying that any resources of type Google Compute Instance, so essentially a virtual machine in Google, the allowed type of that virtual machine has to be in this whitelist array. So what we're defining is that the only machine that I can provision as part of this pipeline is N1 standard 1. And in a real life scenario, you may have additional allowed types here. So this may be a sort of a cost control where you don't want to provision machines that are, that have too many CPU cores and memory just for the cost control measure, right? And now the way this Terraform picks that up is that in the workspace, you'll have a variable section where the Terraform variable machine type has been set to N1 standard 2 that was set by the GitLab runner. So that is essentially why you saw the Sentinel policy violation, is that N1 standard 2 was not part of the whitelisted machine type. All right, so that's the Sentinel portion. The only other item I wanted to mention is that this is the UI for Vault. This Vault instance is running in Kubernetes. Vault has something called a secrets engine, which is where you store secrets. We have a key value secret engine, which is where we are storing the Terraform Cloud API token, and that's really what the GitLab runner is picking up when it sends those REST API calls. And we have a GCP secrets engine, which is a dynamic secret engine, which essentially provides dynamic credentials. In this case, we have a time to live set to about an hour. So after 1 hour, the GCP credential will be destroyed by Vault. So that really are all of the different software and different pieces of code that are working together to enable this enterprise IAC workflow. So Mayank, I'll hand it back to you at this point.
Sure, thank you. That was an awesome overview of the demo and the details. So thank you for that. So I'm gonna go ahead and share my screen one more time, and we'll go ahead and kind of do a quick recap of what everyone just saw. As you saw, that GitLab.com becomes that orchestration engine, the center point of where you kind of execute the pipeline and kick off the automation. Really, with GitLab and Terraform Cloud, you're getting a very cloud-native solution, not just for your application development, where you can deploy to Kubernetes or on the cloud or anywhere, because it's cloud agnostic, but also from a solution standpoint, because Terraform and GitLab are both fully SaaS solutions where you can sign up and get started quickly. It lowers that barrier of entry and doesn't really require any prerequisites of setting up infrastructure, deploying applications to get started, and configuring Terraform and GitLab respectively. As I mentioned before, what you saw today was on GCP, but you can easily replicate it on AWS and Azure by just tweaking a few settings and configurations. And all of what you saw today was code driven. Everything was described in YAML, everything was defined in code, everything was outlined in a spec in one way or form. And really it enables teams to automate via this GitOps workflow for infrastructure as code. Everything is defined and then reliably and consistently executed. It's secure end to end. You can enforce security with GitLab code scanning. We didn't touch on this in this demo, but as part of GitLab Enterprise Edition, you can actually scan for vulnerabilities before your code or application ever hits production or any even staging environments. But furthermore, as you move toward the cloud native architecture, you have many microservices interacting with each other, and even other SaaS services like Terraform Cloud and GitLab that you rely on for your DevOps needs. You can leverage Vault to manage your secrets and any sensitive information or data that needs to be transferred between two services. And then lastly, you saw in this demo Sentinel, how it enforces policy management and making sure everyone's adhering to what they're authorized and authenticated to do. Key takeaways really between GitLab and HashiCorp, we're really bridging that gap between developers and operators, providing them great flexibility, security, and most of all, end-to-end automation. That being said, be sure to check out our demo repository provided in these slides, and feel free to play around and really appreciate you joining our talk and hearing us out. Thanks for joining. Thanks, everyone.